Hey everyone, this is our lesson on gravity and falling objects. So by the end of this lesson, you should be able to explain how the gravitational force affects the weight of an object and the velocity of that object when it's in free fall. So first, let's make sure we understand what gravity is. And gravity is the mutual force of attraction that exists between all objects in the universe. So, like our gravitational force on different planets. Gravity is just a natural force that we experience. If you're ever like walking and you happen to just kind of like you and someone else are walking near each other and you just happen to gradually get closer and closer together, that's a bit of gravity on its own because it's a force of attraction. But gravity, the way that we look at it in physics, does depend on some certain conditions. So mass and distance. We have to look at the mass of the body. We have to look at the distance between the two objects that are experiencing the pull. So the greater the mass of the body that is exerting this gravitational force, the greater that force is going to be. So that's why, like on Earth, we have a stronger pull of gravity than we do on the moon, which is why, you see people, if they're on the moon, they're able to like jump when they walk and kind of float for a minute because the gravitational pull is not as strong because the moon's not as big. And then also the distance plays a big factor because you measure the distance between two objects, and that will determine how strong this gravitational force is going to be. The closer they are, the stronger the gravity is going to be between them. The further they are, the weaker the gravity is going to be between them. So we also have falling objects. And when we're looking at falling objects, we can make a certain declaration about them, I guess, because since we're on Earth, Earth has a very specific gravitational force, which means objects that are in free fall will experience the same acceleration, and that is the acceleration due to gravity. And that is measured at 9.8 meters per second squared. So this is a constant value for the Earth. It is different on every planet because they all experience different amounts of gravity. And our formula for an object that's falling is V is equal to G times T. V is our velocity, which is what we're looking at. G is how we denote acceleration due to gravity. And then T is always time. So let's look at an example problem here. And it says an acorn falls from the top of an oak tree to the ground in 1.5 seconds. What is the velocity of the acorn when it hits the ground? So we know our formula is V is equal to G times T. We've got a G, and remember, this will not be given to you because this is a constant. You need to remember it. Maybe on your reference packet, we can check through that together, but you need to just remember 9.8 meters per second squared. And then we were given a time of 1.5 seconds, so we need to figure out the velocity. We do that by multiplying these two units together, or these two measurements together. But one thing I want you to pay attention to, because units are very important in science, I'm really harping on that here with the physics part as well. We've got seconds squared on the bottom of a fraction here, and we've got seconds on this side. So this is written, just so you can see the units, as meters per second squared. Maybe, there we go, times a second. So if you guys remember anything about math, you know that when fractions are multiplied together, tops and bottoms, you can cancel like numbers or like variables. Well, we've got an S on top and bottom. So we're going to get rid of this square here, and that's going to cancel out with the one S that we have on top, which is going to give us our velocity unit of meters per second, which is how we measure that. So our final value comes out to 14.7 meters per second. Make sure you do not forget units. If you want credit on your checks, you have to show me units. So now I'm going to read this question, then I want you to I'm going to pause, and I want you to try this example. So a rock is dropped from the roof to the ground in 2.8 seconds. What is the velocity when the rock hits the ground? So go ahead, pause the video, and try that. So now let's talk a little bit about air resistance. We mentioned this on our forces video because this is a form of fluid friction if the fluid is air. And this is the force exerted by air on a moving object. So as an object is falling through the air resistance is pushing opposite to the force that the object is, experiencing that gravity pull. And there are some things that will change the amount of resistance that's placed on an object, and that's speed, shape, and size. And with size, we can also consider density. I like to say, the shape and size, the bigger the object or the more space it takes up, not necessarily the weight, but just also like the amount of space it takes up, will cause more air resistance to occur, which tends to slow down an object. So like a parachute, they're not tiny, and that's so air can be caught under them and help slow things down due to air resistance. As an object falls through the air resistance will increase as the speed increases. And the larger the object, the greater the air resistance on it will be. So when we're looking at air resistance, we look at certain measurements, and one of them is constant velocity. And when the upward force of air against the object is equal to the downward force of gravity, the object is no longer accelerating. So it hits, if you look on this little GIF, that plateau that we've got right here, that's our constant velocity. That is where those forces are canceling each other out. So you are not accelerating anymore. You're at a constant speed or a constant velocity. And then terminal velocity is the highest velocity reached by the falling object. I don't know what this means, keep calling at. So it keeps constant at a constant velocity. So when we hit that terminal velocity, it is the highest that we will be. So it is where you will get that constant velocity. Once you get to constant, you're not going to accelerate anymore. You're not going to speed up anymore. So that would be your terminal velocity as well. So when we have falling objects, we can actually look at their pathway that they take as they fall. And when we're looking at the object as it's moving through the air, we tend to call this a projectile. So this projectile, most projectiles will have a curved path, and this is due to gravity exerted on the projectile as well as inertia, which we'll study with Newton's laws. So as you can tell, if you look over here, this feather, it's the lightest of these three objects, which means it's got more of a curved path as it falls. It's experiencing more force that's acting on it. The pencil is a little bit heavier, so its path is a little bit straighter, but you still see that it kind of falls at an angle, and then the rock just falls straight down. We have what's called centripetal acceleration. So this is the acceleration due towards the center of a curved or circular path. So this is when something tries to move to the center due to how fast it's moving. And then we have centripetal force, which is the force that causes a moving object to move in a curved or circular path. And our last term here to know is weightlessness. So when an object is in free fall and it's unrestrained motion within the gravitational field, that's when it experiences weightlessness. So if you think about like NASA training, okay, you have like the zero gravity airplane that takes you straight up and then straight back down, where you experience weightlessness and no gravity because you are actually in free fall.